thank you for letting me come and talk a little bit about one of the projects that we've been working on for the last little while. I know there's a number of people in this room that are working on remote sensing in grasslands. We find a lot of the same problems, which is kind of reassuring in my case. So, detecting grassland change. One of the problems that we have is detecting grassland change, we don't have the baseline to start with. So how can we detect change? Grasslands, very important for the cattle industry, very important for different species. Some are under threat of extinction. Important from the point of view of hydrological and carbon cycling. And also, very important, they're under threat. And in the particular area that we live in, near Lethbridge, one of the biggest threats is changes to irrigated agriculture. And changes to irrigated agriculture not only remove the grassland, but they also put additional strain on the water resources that we do have. We have a lot of urban development, we have a lot of oil and gas activity. In actual fact, one of the projects that we did back in 2004, we went out, we had done some work we did the work in 2004, 2005, we went back out to our test site and it now became a right of way for oil and gas. So we lost our test site in that particular year. And I have some colleagues that are working at the Lethbridge Research Station who are into biological control. So they have an interest in controlling things like leafy spurge in grasslands. Grasslands have been disappearing. There's a lot of stuff lately in our newspapers that are increasing attention to the public about what's happening. In this particular case, it was a potato gate. And the question of whether 99 quarters would go from grassland into potato production. There are some pilot studies that have been done on what is the state and how much grassland do we have left, and they've come up with a number of different scenarios, but they have declines that we have in the different levels of grassland worldwide and also within the prairies. And really, in Manitoba, we've lost a lot of the grasslands. So there's a lot of awareness around the grasslands and their concern, but what is the status of it? And I got a lot of questions about, people would phone you up and say, well, is there any information on how much grassland has changed? And it's like, nobody has a database that would tell us that sort of stuff. So we, in 2008, put in a proposal to look at developing our conservation tools for monitoring grasslands. And we had three particular objectives. One of them was the spatial extent of the grasslands, looking at net primary productivity, and also invasive plant species. We mapped some of those using remote sensing. And obviously, to do that kind of work, you need a rather large team, and this is the team that we built in order to do that particular project. So we have grasslands, which are of concern to a number of different people. So we have some university people who are interested in ecosystem modeling. They also have some expertise in some of the analysis of the remote sensing data. We have federal in terms of assessment policy. We have provincial, and we've done a lot of work with Barry. Municipal, we have some of the land managers, so we've gone out to some of the lands to do our work and we talked to them about what we're doing. We have some industry people from the Alberta Terrestrial Imaging Centre and Terra Vista Earth Imaging, and then we also brought in some NGOs, so we have Alberta Conservation Association, because ultimately all of us are interested in the same things. So in terms of spatial extent and fragmentation, there are a number of spatial databases out there. Agriculture and Agri-Food Canada has a grassland mass that comes from the crop inventory. Agricultural Financial Services Corporation have a grassland mass. There's the Alberta Native Prairie Baseline, the Alberta Grassland Vegetation Inventory, and also I learned from Barry the other day that there is this Alberta Primary Land Vegetation Inventory that's due to start in 2014. So we have a number of these inventories, and the question are, can we update them? How are we going to update them? And in the case of the GVI, it was a fairly expensive business with airborne imagery, so is there other ways that we could look at updating it? And perhaps also, we have a legacy of Landsat imagery that goes back to 1982, so do we have the potential to go back then and look at some of the issues in terms of how much have we lost? Some of the problems that we have when we go back to that is that we don't have a lot of validation data in order to say that we're doing a good job or a bad job. So this was my introduction to remote sensing, and this is a spot image. So anything that's red has lots of vegetation, anything that's blue is a little less vegetation, but this little line here is the 49th parallel. So you're not telling me that the land changes so much that we get this transition across it. And interestingly enough, the people that helped me process this first image did it 3 times because they thought it was a flaw in the image. So it was a really telling one that we had. But we went in and we did some classifications on that. We used some ground data that we got through insurance programs, through irrigation districts. We also used the native prairie baseline. And we came up with a classification, and in this case, anything that's kind of the brown color is rangeland, and anything that is in the ivory color is non-rangelands. And we built in some rules too, because we did have some grassland, some rangeland crops appearing down in these valleys here. So we built in some rules using some of the soil parameters that we know and some of the topographical information to say, well, in that area we really wouldn't have a cropping system. So we built some of those, and we looked at 1-4 as a relatively stable area. There's not a lot of change that's happened over time. The other area that we looked at was up in Newell County, which has a lot of oil and gas activity, and there's also a lot of irrigated agriculture. And when we looked at from 1999 to 2005, the things that pop out are all these irrigated circles that have changed from grassland to irrigated agriculture. We do have some other stuff that's going on here. We have some noise in our data because depending on the year, you may have a dry year, you may have a wet year. So some of the corners of the pivots are growing a lot of stuff, sometimes they're not. So there is noise in there. We just have to accept that's one of the limitations of our data. But this got Barry quite excited because we could tell him where these irrigated areas were coming in. Part of the problem with that is obviously the validation of the data, and what we did do was we sent all these maps out to various organizations, and they left it on their coffee table, and they'd all come back and they'd mark it for us. So we knew where we were doing a pretty good job and also not such a good job. And from there we can go to the county level, and we can get areas of change that went to grassland. This one we don't think is probably right. We think it's a function of the amount of growth in the crop, but we can get some reasonable estimates of the area of change. So we looked at some historic stuff. Now we're looking at trying to do some baseline. And one of the things is that Canada has committed to the radar constellation. So Canada will be launching 3 radar satellites. So can we use that data rather than optical data? The advantage of radar being that it's so-called all-weather. I don't know whether I call it all-weather because you can see where there's a swath of rain going through, you will find that you can actually see that on the image. So I don't know if I call it all-weather, but we can acquire the data in the morning or at the night or in the evening. So on the left here, I have the Landsat image. That's an optical sensor. And this one is the radar, and they look fairly similar. And if we go in there and we classify the image, we come up with something that is fairly similar. So we're thinking that these actually, we might be able to use radar where optical is a bit of a problem when we have cloud cover. So we're looking at some of those things. In Alberta, we're very fortunate that we had the native prairie vegetation inventory. That was a corridor section scale. So it was whether native range was present or absent in the quarter section. And then more recently, the grassland vegetation inventory, which a number of people in this room are involved in. It was created using color infrared digital airborne imagery, and it's a comprehensive inventory that includes biophysical, anthropogenic, and land use information. Rather than the quarter section, it's polygon based. And the size of these polygons could be 5 hectares to 1 hectare. And the accuracy is believed to be greater than 90%. So we have this database, this wonderful database in Alberta, that we could use as our current baseline, but how are we going to update it? This shows you this is the GVI, so that the yellow lines are the soil polygons, and then the blue lines are how they've been broken up into these different GVI polygons. And with each of these, there's an attribution of the kind of vegetation present. So our interest was, how are we going to update this? If this is a scenario that Barry kindly provided for me, if this is my GVI where the green is what we see as a native grassland, and it has its attributes here. We go along later on and we get some imagery. What kind of imagery is still to be determined. And we look at whether things have changed. So in this case here, this area has now changed to cultivated. We isolate that polygon, and then we can update the GVI. So the question is, what kind of tools could we use in order to update this? Well, one of my colleagues that I work a lot with is Michael Hill. He's at University of North Dakota, but he's originally from Australia. And he did an awful lot of work in the savannas in Australia. And he's been working on whether we could basically have what we call spectral fingerprinting. So we could use different areas of vegetation and look at the different vegetation indexes that we can create from those images, and look at whether they vary over time, and do they vary between cover types. So we've got grassland with sparse trees, and then if I look at medium woodland with grassland, it's a slightly different vegetation. The vegetation indices change slightly. So the question is, can we do that with the GVI? So we were very fortunate that we got some imagery back in, I think this was 2009, and it's an experimental satellite called Hyperion. But the beauty of Hyperion is it lets us use a lot of different bands that will let us simulate future sensor systems that are due for launch in the next few years. And this just shows you some of the vegetation indices, and all these polygons are the GVIs. So the question is, if we looked at polygons that were a certain type of land cover, do they have a spectral fingerprint? And one of the things that comes out is, if we look down here, this is a road down here. So we suspect the management practice is different across here, but the GVI polygon is one polygon. So that's what we're looking at right now, is whether we can use that in order to try and update the GVI, or have a tool that we can then use to update the GVI in future. So that's one thing that we're looking at. We're looking at it from the perspective of the Landsat Data Continuity Mission, and also Sentinel-2, which are two new satellites that are scheduled to go up in 2013. One of the other things that we have with oil and gas exploration, this is a study that was done again in Suffield. So these are some air photographs prior to 1997, again courtesy of Barry. Here it is in 2001, same area. So we've got all this gas and oil exploration. And if you add it all up and you classify it, we can look at the losses in grazing in those areas due to oil and gas infrastructure. And we have a number of satellite systems now that are down at the resolution of the airborne imagery. So the potential to do this still exists. We tried to do it with some spot data, which is a higher resolution, lower resolution satellite, but we didn't have as much success. Another aspect is invasive plant species. And in Canada, from reading, there seems to be 116 in the prairie region, which seems like a lot. And the problem is the economic impacts of those. So in one study of 16 invasive alien species, it's estimated to have cost $13 to $34 billion per annum in the loss of grazing, in the control measures that are required, and just basically in the loss of the resource. There's also, some of them are unpalatable or toxic to wildlife and to domestic livestock. And the ecological aspects are that they compete for water and other resources, and they drive out these native species, sometimes to total or extinction. One of the invasive species that has occurred due to oil and gas reclamation is crested wheatgrass. And you can see here that it was used in reclamation, but it tends to spread out. So the question is, can we look at that, and can we come up with a way of looking at the invasive species with remote sensing? And in 2008, a student that we had at the university did an independent study where he was looking at whether we could track some of these invasive species. And here we have, the red in here is what we're predicting is crested wheatgrass, and the yellow is bare soil. So if we look at the Google image in here, we seem to do not too badly where we get crested wheatgrass around abandoned wells, and we get it along some of the roadways. So we thought, oh, well, maybe this is pretty good. Maybe this will work and we can get a map of invasive species along some of these oil and gas exploration sites. The problem was when we went to 2007 and did the same thing, we got all this noise in here. And 2007 was a much drier year. So we have a lot of bare patches, and we have some that are showing up as crested wheatgrass, which may be low spots where we have higher productivity. So these are some of the things, the problems that we have when we look at remote sensing, which is a snapshot in time, that from one year to another it changes. And therefore our capability to detect that also changes. The one that I'm really involved with is with my colleagues who are in biological control, and they're mapping invasive species along the grasslands in the river valleys, in the river valley here, and their issue is they don't really find it until they go out and look for it. And then when they go out there, they take a GPS point and they have point data along there. They're not sure how expansive that particular colony or that particular invasive species is. So one of their questions was, can we use remote sensing to do this and to give them a tool that would let them map the extent of that invasive species, but also to go back once they've released their insects or they've done control measures to see how effective they've been. So the one that we're working on is leafy spurge. It's thought to occur in 5 million acres in 15 states and 6 Canadian provinces. And in Manitoba alone, there's thought to be 340,000 acres. I know in Manitoba and Alberta, there's a lot of acres too. And the economic impact, there are a couple of studies that have looked at the economic impact of this particular weed species, and you can see that the numbers are pretty large. And it all stems from the fact that you have to control it. We have a loss of forage, we have a loss of livestock. So my colleague here wants to be able to release these beetles that do a very good job, as Bev can testify to, in getting rid of this particular species. So can we use remote sensing in the inaccessible areas to look at these invasive species? It has been done in the US, but it wasn't widely adopted. So the question is, why not? So the question I had was, is leafy spurge present in the quarter section, yes or no? Well, we did a study where we flew some aircraft data, and this is not a canola field, this is leafy spurge. And you can see that there's a large infestation in here. We had a number of sites that we looked at, and we collected airborne data. We look at the spectral signatures, and we try to identify a spectral signature that would tell us it's leafy spurge and not something else. We go on the ground and we do all sorts of field sampling. So we had 4 sites where we had 100 by 100 meter grids. We sampled every 5 meters in that grid. And in a lot of cases, every sample point we took a digital image, a photograph, and then we did manual stem counts in a lot of them, and we could then quantify the digital image to come up with our ground truth data. So then if we look at these 2 sites with our airborne data, the crosshatch is where, from our analysis, we're predicting we have leafy spurge, and the dots are where we have the actual stem counts of leafy spurge present. So we seem to be doing not too badly in estimating some of the leafy spurge, but not in other cases. And if we look at the number of pixels in our image that we know have leafy spurge from our ground data, because every pixel in here is 2 meters, and we've gone out, we've sampled that 2 meters. So we know how many pixels actually have leafy spurge, and we look at what we predict to be present. We don't do a very good job when we have low density, when we have 1 to 15 stems. We don't do a very good job when we have 15 to 40 stems, but we do a good job when we have over 40 stems. And our biological control friends will not be releasing insects below 40 stems because there aren't enough stems to maintain the insect population. So they're quite happy with this. If we can identify high density, then we could do a pretty good job. We were fortunate, we went back out and looked at some of the other parts of the river valley down here. Here's where we predict it is, and the little red dots are where we found it with a GPS. So we reckon we're not doing too badly in estimating the leafy spurge. Now to take it up from the aircraft, we did get some imagery. One of them actually is the same time as we flew our aircraft, so that's really nice. And we also have some from one of the community pastures in Elbow. So the question is, can we extrapolate up from the airborne to the satellite imagery and come up with some estimates of leafy spurge invasion? Estimating annual productivity, that was one of the other goals that we had, whether we could estimate the amount of production of grassland. We used, again, Barry has a great data set. These are some of the sites in southern Alberta where they've been collecting information on productivity from anywhere from 1986 to the current. We picked 3 sites in the province that went from west to east, so they were from higher productivity down through lower productivity. And in 2 years, we collected ground data for those. And we got some Landsat images, and we tried to figure out whether we can, from remote sensing, estimate the amount of grass that's present. So at each of our sites, we had 5 transects, and the dark filled bars, the darker bars, are our ground truth. So this is the fraction of green vegetation present. This is the fraction of non-photosynthetic, so in other words, standing senescent material, and then background. And the dark bars are the ground data, and the light bars are what we're estimating from the satellite remote sensing. So we did a pretty good job in 2009. We went back in 2010, and our relationship is not quite so good. So there's a number of factors that come in and out that seem to be a bit of a problem. I think probably climate is one of the big ones. But we can take this data and extrapolate to a map where you can get fractional cover of the amount of photosynthetic, which ultimately would relate to biomass, the amount of standing senescent vegetation, which is not litter. We can't get to a lot of the litter because the sensor will not see underneath the thatch, but we could get to standing. And we can look at ground, bare ground as well. So we have some maps. We're looking at the 2010 data again to see whether we can do the same thing. There is also this wonderful data set from the Rangeland Reference Area Monitoring Program, which, as I've said, has data from 5 to 20 years. It's clipping data. It's spatially discrete, though. There are a number of cages where they go and they take these clips. Now the question is, can we use remote sensing not to replace what they're doing, but to extrapolate over the landscape? Because these points here will always be our validation of whether we're in the ballpark or not. This just shows you, this one here, this is an exclosure, and this is the clipping data. We have all the information about the species composition, the soil types, and then we have all the clipping data for the number of years. So we went back. I went and looked with, again, some remote sensing. I used 29 sites and 3 different community types. And we looked at the relationship between the vegetation indices and the clip data. And we do get quite a nice relationship in some years. And if we look down here, we get some nice relationship. It's a bit better in 2009. This one is a bit better in 2009, and in the needle and thread, it stayed kind of constant. So with our clip data, we look like we get a pretty good relationship. The question is, which is the best index to use? So we're working on some of that. When we look at the exclosure data, then you see that the relationship falls, except on the northern wheatgrass, and it fluctuates from year to year. And we think a lot of that is due to the carryover and the senescent vegetation. when the green is coming up through the senescent vegetation, we're having some issues in terms of trying to identify the photosynthetic materials. This one just shows you where the exclosure has more non-photosynthetic material, which we think is part of the masking problem when we're trying to estimate the biomass. One of the other things that we've done is that if you look through, the US has a program called RangeView, and their RangeView program looks at the deviation of MODIS data from year to year. So they've averaged over about 10 years, and they're looking at whether your vegetation index is higher or lower in the year, and from that they're coming up with whether we could expect more production or less production. In this case here, this is for the state of Arizona. In 2001, we have below average, but in 2003, we have above average. And so you can go in and you can get every month what's happening there and how much production there is. The other one that is out there is a program in Australia called Pastures from Space. Very good name, I guess. And it basically uses a land use efficiency model to try to come up with estimates of grassland production. It's actually gone commercial now, and they have a program called Pasture Watch, where you can buy in and you can buy the information, well, you can get the information for your pasture every week and whether you're getting good production, low production. So these are just some of the maps that come out. They look at the pasture growth rate over time. So in this case, this is in August, and then in October. So you can see that it fluctuates up and down depending on the season. And you can go back and you can get any county in there that you want, and you can find how the pasture growth rate has changed over time and over years. Very nice program. So the question was, can we adapt that to the Canadian prairies? Well, we're working on it right now, again with my colleague, Michael Hill, who was one of the early instigators of the Pasture in Space program. Basically what we do is we use remote sensing data to come up with an estimate of the absorbed photosynthetically active radiation, and we build it through a model, but we also build in the limiters, which are the moisture and the temperature. So we go in and we get all the temperature data, and we come up with whether the temperature is at the point where it's optimal for growth or not optimal for growth. We also look at the moisture, whether there's moisture stress, so we use the climate data to come up with the amount of precipitation, the amount of evapotranspiration. And we've also extracted all the soil information, so basically we know what the wilting point is, we know what the field capacity is, and from that we can have modifiers. And here we have our first look at this, where we're looking at production of different community types and of different years, and seeing what sort of things we come up with. It's not the best relationship in the world, but we also only used a single light use efficiency parameter, and we are looking for root to shoot ratio information because we want to look at above ground, not below ground. And it's hard to find that for native grass. So if anybody's got any of that information, that would be really nice, because that's a very hard thing to find. So we're going to work a little bit more on that. Hopefully in the near future we can ramp that up, because we have now more than 10 years of MODIS data, and we've also got barriers data, so we have a whole suite of information that we can work with. The future, well, there's many satellites out there, both ones that are funded by government agencies, ones that are private. They have a multitude of spatial resolutions, spectral resolutions, temporal resolutions. They also have a lot of different costs. Some are free and some are lots of dollars. So it depends what you want to do with it. But in my mind, the challenge that we have is to understand the needs of the end users. What do they need? And to understand the dynamics of the grassland system and its effects on the ability to monitor that with remote sensing. We seem to be able to do it some years, and other years we don't. But why is that? Can we understand that? And also, I think one of the things that I believe quite strongly in is that we have to recognize the limitations of remote sensing. Remote sensing will not be the panacea for everything, but it can be one layer in helping you get some of the information that you require. And there's a number of people that have helped in looking at this work, and a number of them are still helping me look at this work. So I'd like to acknowledge them and thank them for their contribution. And with that, I will say thank you.
We have a few minutes. Any questions? Yeah, clarification? Right on. Good.
I have a technical question. You mentioned you use satellite imagery to identify the non-photovoltaic vegetation. So I wonder, how did you identify NTV samples from imagery? What resolution imagery do you use?
Right now we're using MODIS data because without that we won't get the temporal resolution that we need, because we obviously need the temporal resolution. So with the MODIS data we're using the Canada Centre for Remote Sensing 10-day composite. So we feed that in to get the fraction of absorbed photosynthetically active radiation using the NDVI, and then we pass that through the modeling component to come out with our estimate of net primary productivity. So there's a number of factors in there, like I glanced over it all in that.
Yeah, for the MODIS pixels to course highly mixed field, how did you identify MTV?
Okay, right in the minute we use we're using areas that we know have large tracts of native grassland. One of the things that we did do was the MODIS pixel is 250 meters. So we went into Landsat and we looked at what was the variability in the Landsat pixels within that MODIS. And we came up with areas that are highly variable, and they seem to be a bit of a problem when we're trying to estimate stuff. And then there's other areas that are very similar, the standard deviation is really low. So it depends on the situation, and it depends on the site that we're looking at.
Thank you.
Yes.
In Canada, you have to pay for the Landsat data, or do you get that for free?
We get it for free now.
Do you know how much will the radar data be available?
Right now I get it for free, so somebody else might be able to help that. Ian, do you know?
What was the first part of the question? I couldn't hear.
What cost is RadarSat data going to be?
Government of Canada invested in the satellites.
So we get
So we have a certain
yeah.
big chunk of data that we get free. And the next mission that you referred to, the RCM, it's got a fairly open data policy, and
Right.
it's kind of a Canada first policy, so that would be free as well.
So what about in somebody in the United States?
Definitely the opportunities to get free data would be better with the RCM. Currently, you'd be dealing with the commercial entity attached to RadarSat and MDA, and there'd be a cost. Unless there's a cooperative program with the Canadian research.
Yeah, maybe we'll give you some of our Landsat, the new Landsat, if you give us some of your radar data.
Well, the whole world's becoming way more open with sharing data, so that's definitely the model we're moving to. It's just we have to deal with old legacy agreements right now.
Okay, well, I think in the interest of time, we'll move on.